Welcome, in this one we're going to take a look at finding the area in the context of integration using polar coordinates. So here what I have is the following. Let me go through this a little bit. So given is that r equals 2 cosine a is the angle, and then r equals 1. So I'm not going to show you the detail of sketching these out, I'll just show you the final pictures. So this blue circle that you see that represents r equals 1. So that's a circle of radius 1 around the origin. Everywhere you go, it's 1 unit, say between where my head is, which is the boundary, over to the origin, 1 unit, all around. That second piece, r equals 2 cosine a, well, that's the red circle, you see? So that basically looks like a circle in this position right here, where my head is tracing. That's the boundary of that circle. And what we're going to do is focus on finding the area between them. So in other words, this area right here, okay? So this area where I am located is outside the blue circle, but inside the red circle, right here, okay? So what are we going to do here? Well, we're going to take r equals 2 cosine a and set it equal to r equals 1. That's going to give me a small equation that says 2 cosine a equals 1. Then divide through by 2, that's going to give me cosine of a equals 1/2. And then when I solve that by using the unit circle, that's going to give me a equals pi over 3. Now, because I've taken the time to sketch this, I'm going to use symmetry as follows. This portion where I am located right here above the x-axis, the value there would be the same as the value below the x-axis because it's symmetric. So what I'm going to do for that reason is integrate from a equals 0. Remember here, a is the angle, or if you like theta. So the angle from a equals 0 up through pi over 3, which I got by solving this equation that I got set up by doing 2 cosine a equals 1. Simple enough, because that's where the two circles, as you can see, meet at that point above my head. Okay, I hope you've got all of that. And I'm going to do it from a equals 0, but that means I'm ignoring this portion below the x-axis. So when I create my integral, I have to multiply by 2 for that reason. So let's set up the integral. As a reminder, I'm going to use this formula. I'm going to integrate from c to d, 1/2 r squared dA, or if you like, often this is written with theta because theta is commonly used for angles, but it's just a letter in the end. So first I'm going to have a green 2 outside the integral. The reason is that I'm going to focus only on finding this upper area, which means multiplying by that green 2 outside also will give me the lower area. And I'm going to integrate from 0. So again, the reason is that that's like the starting angle. It's the one basically along the x-axis. And I'm going to integrate through pi over 3, which is where they meet right there, okay? So that's pi over 3, and it's going to be 1/2 2 cosine a quantity squared minus y 1 squared dA essentially. So what I'm going to do is I'm going to take that black 1/2 and factor it outside and multiply by the green 2. So it's going to be 2 times 1/2, 0 to pi over 3. Then I'm going to take this black 2, I'm going to distribute it over to the red 2 and the cosine. So it's giving me 2 squared times cosine squared of a minus 1 dA. Usually, again, I want to stress this, you'll see this as d theta. I'm just using a because it was easier to type. So then after that, the 2 squared in that position above my head, that's going to become this green 4. That green 2 times the 1/2, that's going to become a 1 on the outside of the integral. And then also this is going to become now cosine squared a minus 1. Continue. So what I'm going to do is there's that 4 right there in front of me, or above my head rather, in front of me. I'm going to put that above my head now as 2 times 2 cosine squared a minus 1. The reason is that 2 cosine squared a can be replaced with an identity easily, okay? That's why I wrote that 4 as like 2 times 2. I didn't leave it as 4. Okay, outside the integral I have a 1 now, notice. So this red part, 2 cosine squared a, that will be replaced with 1 plus cosine of 2a. That black 2 is kept, and the purplish or bluish 1, that's also kept in this position. So just making a replacement using a trig identity. Continue. Down below here. So now I'm going to have that 2 distributed over to the 1 and the cosine, so it becomes 2 plus 2 cosine 2a minus 1. So what I've done is back here at this step above my head, there's a 2, you see, so I distributed to the 1 and the cosine of 2a. So it's going to look like the following now. From integral 1 times, the integral from 0 to pi over 3, 2 plus 2 cosine 2a minus 1. Now I'm going to combine here because it's 2 minus 1, that's going to give me a 1 in this position right here, okay? So integral 0 to pi over 3, 1 plus 2 cosine 2a dA. Now what I'm going to do is I'm going to distribute the integral symbol because it's got a basic property where you can distribute it. So I'm going to distribute that over to the 1 and the 2 cosine 2a individually. So it's going to give me the integral from 0 to pi over 3 of 1 dA plus 2. So here on this part, that 2 above my head right there, I factor that. So I distribute the integral symbol and I put the 2 outside because it's constant. So it's going to come out as 2 over here. Then it's going to be from 0 to pi over 3 of cosine 2a dA. Continue. I'm going to now antidifferentiate 1. That's going to give me an a in this position. Then I'm going to do the antiderivative of cosine of 2a, which is sine of 2a. You can check it if you like, because the derivative of sine of 2a would be cosine of 2a. That tells me that it's correct, okay? So the antiderivative is a plus sine 2a. I'm going to evaluate this between pi over 3 and 0. So plug in pi over 3, the upper limit of integration. It's going to give me pi over 3 plus sine of 2 times pi over 3. And then here I'm going to replace a with 0. And then also sine of 2 times 0. When I plug in the lower limit of integration from that position above my head. So it's going to be pi over 3 plus sine of 2 times pi over 3 minus, within parentheses, because it's 2 or more terms, 0 plus sine of 2, 0. Then we clean that up. The terms above my head, well, 0 is 0, goes away. Sine of 2, 0 is just sine of 0, which is 0, goes away. So all that remains is really pi over 3 plus sine of 2 pi over 3. And if you want, you can look it up in a unit circle, and you will see that it looks like the following down below. Pi over 3 plus the square root of 3 over 2. That square root of 3 over 2 I got from the unit circle as the value of sine of 2 times pi over 3. In other words, this quantity on my side is the answer. That is it. Thank you so much for watching. I hope it's detailed and useful. Please leave a like and subscribe. I'll see you in another video. And stay well in this time of the coronavirus. I live in Queens and it is a somewhat scary time right now. But nevertheless, we must persist.